but I find only Hamad said that he gave a try, but he didn't get. That what is the main problem for finding the parametric equation is that we have to find the parametric equation for this rectangular shown in a figure. This is the rectangle, okay? That is a rectangle is traced counterclockwise. Okay, counterclockwise means in this direction. This is the direction. Okay, so this is the counterclockwise, and t varies from 0 to 1 because we have a limit of t that varies from 0 to 1, starting at a point half and half. So this is the point, this is the point, this one is the point half and half where the graph starts, okay, and it moves counterclockwise from this side to this side to this side and then this side, okay. So this is the direction and we have to find the parametric equation for these, okay. The given data is t is less than equal to 1 and greater than or equal to 0. Okay, now I want to ask from you how many parts of the rectangle are. How many parts or sides of the rectangle have? This is the first side, this is the second side, this is the third side, and this is the fourth side. Okay, so for each side there must be one parametric equation, and we have an interval from 0 to 1. So for this we have to divide t in four parts. Okay, t is between, you can see here, this is, for example, if I say this is 0 and this is 1, I have to divide this into the four equal parts: 1, 2, 3 and 4. This is the first part, okay. This one is the second part, this one is the third part, and this one is the fourth part, okay. So this point will be 0.25, this point will be 0.5, and this point will be 0.75, right? So I divide equal parts of the t. So this part means t is in between 0 and 0.25. Okay, this part, the first part, the t interval is this one. Now for the second part, the interval is 0.25 to 0.5. Okay. Now the third interval, third interval is 0.5 to 0.75, right? And the fourth interval, the last interval, is 0.75 to 1. Okay, so this is the four parts of t I divide because we have four different sides of rectangles. Okay, so for this one we have one side, for this one we have one side, for this one we have another side, and for this one we have another side. Okay, so this point is clear how I divide the four parts of t. This point is clear. Okay, now see, now these are the points. Okay, 1 by 4 means 0.25. Okay, so I write in points, so you can write in fraction. So this is 0.25, 1 by 2 is 0.5, and 1 by 2 is 0.5, 3 by 4 is 0.75, 3 by 4 is 0.75, and this is 1. These are the four parts. Okay, now see, what is the first point The first point is this one, and the first part is this line. The first part is this line. At this line, the y is fixed. Y is fixed, which is 1 divided by 2. I write here 1 divided by 2. For the first part, only x change, not y, because y is fixed. For every horizontal line, y is fixed. For every vertical line, the x-axis is fixed. Okay, again, for every horizontal line, y-axis is fixed. For every vertical line, x-axis is fixed. Okay, so this line is horizontal line, so we have a fixed value of y, which is 1 divided by 2. Now we have to divide, and here the value of x is 1 by 2. I write 1 by 2. Minus times, whenever you move from right to left, and up to down, you will use negative sign. Okay, this motion is from right to left, so we use here negative sign. Whenever you have left to right motion and down to up motion, you will use here positive signs. Got it? Okay, now this is right to left motion, so I write here negative sign. This is the fourth part. Starting with 0, so you will write 4 into t minus 0, the first part. Okay, the second part will be t minus 1 divided by 4. The third part will be t minus 1 divided by 2. The fourth part will be t minus 3 by 4. Okay, now see the second part. The second part is up to down. Up to down means you have to fix the value of x. I fix the value of x. Now the value of y is 1 divided by 2. It is up to down, I make it negative. This is the fourth side. Fourth we have to write because we have 4 sides of rectangle. Okay, and t minus 1 by 4 means it is the second part, starting with the second part. I explain here, when you write t, this is 0, this is 1, this is, you can say 1 divided by 4, this is 1 divided by 2, this is 3 divided by 4. Okay, this is the first part, start of first part, so I write t minus 0. T minus 0 means t, so you can write 4t. The second part starts with 1 by 4, so I write here t minus 1 by 4. The third part starts with 1 by 2, so I write here t minus 1 by 2. The fourth part starts with 3 divided by 4, so I write t minus 3 by 4. Okay, now see the third part move with left to right, so left to right, so you have to take positive sign. Okay, so using these 2 points you can easily calculate these 4 parametric equations. Got it? Anybody who didn't understand, tell me. Anybody? Got this example or not? Okay, good. So now go towards the next topic, which is tangent line to parametric curves. Tangent line means you have to find the slope of the parametric equations. Slope of tangent line by using these parametric equations. In 101, you have one function and you want to find the slope from that function. Okay, so now we discussed before that if you have one function, you can convert that function in a parametric equations, and from parametric equation you can find the slope. So we have a formula to find the slope, is that dy by dx is equal to dy by dt and dx by dt. Okay, dy by dt and dx by t, and there is a condition that dx by dt should not equal to 0. Okay, for example, if I give you example, x is equal to 4, y is equal to sine of t. Okay, if I say that find the slope of this parametric equation, what is the derivative of x with respect to t? Anybody can tell me? What is the derivative of x with respect to t? The derivative of 4. Anybody? What is the derivative of 4? The derivative of 4. 0. Very good. The derivative of 4 is 0. It means that this is equal to 0. But the condition is that dx by dt should not equal to 0 for finding the slope. So in this case, we cannot find the slope, or you can say for this parametric equation there is no slope. Okay, got it? The first condition is that dx by dt should not equal to 0, and you have to use this formula when this is not equal to 0. Okay, so this is the example. First example is that we have to find the slope of the tangent line to the unit circle when we have this parametric equation. Okay, x is equal to cosine of t, y is equal to sine of t, and at the point t is equal to pi by 6, we have to find the slope, and we have to fix the point of t is equal to pi by 6, and we need the slope of this equation. Okay, parametric equations given, points are given. Now we have to find the slope of this parametric equation. Okay, and now what are given? X is equal to cosine of t is given, y is equal to sine of t is given. Okay, we have to find the find the slope. Okay, we have to find the slope. This is, and the formula for the slope is dy over dx is equal to dy over dt divided by dx over dt. So this is the formula for the slope. Okay, now from the first equation, from this one, can you tell me what is the derivative of t with respect, what is the derivative of x with respect to t? What is the derivative of cosine of t with respect to t? Anybody? Cosine derivative. What is the derivative of cosine? Minus sine. Very good. So the derivative of cosine is minus sine. And for this one, what is the derivative of sine with respect to t? That is equal to cosine of t. Okay, now substitute, this is not equal to 0, we need that this should not equal to 0. Okay, so substitute these two values in the formula. What we will get? Dy over dx, that is equal to dy over dt is equal to cosine of t divided by dx over dt is equal to minus sine of t, minus sine of t. Cosine over sine is equal to what? Cotangent of t. Okay, but we need the slope for t is equal to pi by 6. So we have to fix the point for t is equal to pi by 6. What we will get? Minus cotangent of t is pi by 6. I put the pi by 6 value. From the calculator you can calculate this is equal to negative of square root of 3. So this is the slope of these parametric equation when you have the point t is equal to pi by 6. Got it? Just you have to find the derivatives. If you know the derivatives, you can easily find the slope of any parametric equation. Okay? Is this clear? Okay. Now the second example, that you have to find the parametric equations but without elimination of t. This is the equation that without eliminating the parameter, okay, you don't need to eliminate the parameter t. You have to find the dy by dx. Okay, we have the formula. You have to find the double derivative. Okay, first derivative and double derivative or with respect to x at 0.11 and at 0.1 and minus 1 on the semi-cubical parabola. And we have parametric equations x is equal to t square, and we have the second parametric equation y is equal to t power 3. So using this two parametric equations, we have to find dy by dx, and we have to find d square y over dx square. Okay, so what are the given things? That the given things is x is equal to t square is given, and y is equal to t power 3 is given. Okay, and the points are given 1 and 1, and the second point is given 1 and minus 1. For these 2 points, we have to find the first derivative and second derivative. Okay. Now, the formula, what is the formula for dy over dx? We know that we used before dy by dt divided by dx over dt. So this is the formula. Okay. So if you say this is equal to, for example, y dash, this is equal to y dash, so you can use this formula. Now, what is the derivative of x with respect to t? Anybody can tell me what is the derivative of x with respect to t? That x is t square, t power 2. So what is the derivative of t power 2? T power 2, yes, 2t, very good. And what is the derivative of dy over dt, which is equal to t power 3? 3 t power 2, right? Okay, substitute these two, yes, substitute these two values in this formula. What we will got? Y dash is equal to what? Dy by dx. Substitute here, and here what we will get? 3t square divided by 2t. T and t cancel, we will get 3t divided by 2. So it means y dash is equal to 3 by 2 into t. Okay, this is the first derivative. Now we have to find the second derivative. So second derivative formula is this one: d square y over dx square is equal to dy dash over dt divided by dx over dt. Okay, for this value we already have, this is the value. Okay, for this one we need to take the derivative of this one with respect to t. So dy dash, doctor, sorry, the connection is weak. I have now entered. Okay, no problem, Abdullah. You can see the recording, okay? And if you didn't get the first two examples, then you can say me in the next class. I will explain for you. dy by dt, that is equal to 3 divided by 2. Okay, substitute this value and this value in this formula. Okay, what we will get? What we will get? See, d square y over d square is equal to 3 divided by 2 divided by 2t. If I simplify this one, that I will get 3 divided by 4t. 3 divided by 4t. Now we have first derivative dy over dx, that is equal to 3t over 2. We have second derivative, that is equal to 3 by 4t. Okay, now we have to find the points to put in the value of t. So I'm present or absent? Present, no problem. Okay, for the points, it is given that first point is 1 and 1. Okay, welcome. And the second point is 1 and minus 1. So we have 2 points, t is equal to 1 and t is equal to minus 1. When I put t is equal to 1 in these two equations, what I will get? dy over dt dx, and t is equal to 1. I got 3 divided by 2 into 1, which is equal to 3 divided by 2. If I put 1 here, that will d square y over dx square, and t is equal to 1. That will give me 3 divided by 4 into 1, which is equal to 3 divided by 4. Okay, for t is equal to minus 1, I will put in these two values, dy by dx, t is equal to minus 1, which is equal to 3 by 2 into minus 1, which gives me minus 3 divided by 2. Okay, so for the square, you have to use the same, t is equal to minus 1, that is equal to 3 divided by 4 into minus 1, which is equal to minus 3 by 4. Okay, so these are the points. This is the first derivative when t is equal to minus 1. This is the second derivative when t is equal to minus 1. This is the first derivative when t is equal to 1. And this is the second derivative when t is equal to 1. And these are the general slope equation for t is equal to, for second order derivative, and this one is the first order derivative. Okay, got it? Understand? Just you have to use the simple calculations. If you know the derivatives, you can easily find the slope of any parametric equation. Okay, see this one. Here in this notes there is a mistake here. This is not this one. This is minus cosine of t divided by, not this one. Okay, I will write here. It is not this one. This is cosine of t minus sine of t. Okay, because this is x is minus sine of t, y is cosine of t. In formula up is y, so it should be cosine of t minus sine of t. Here this one is I write right, but this is a mistake. Okay, you have to be careful when you see the lecture notes. Okay, that's why I solve in the whiteboard. Okay, maybe I write here wrong, so you can see in the lecture you will find if we have any mistake. Okay. So this is the second problem, that is t square we calculated and we got these values. Okay, now the third example is that we have to find dy by dx and we have to find d square y by dx square, and we have the parametric equations x is equal to secant of t and y is equal to tangent of t, and we want for the single derivative and the double derivative for t is equal to pi by 3. Okay, using the above method we can easily solve this one. I will explain here. See what are the given conditions, that t is equal to x is equal to secant of t and y is equal to tangent of t, and the point given t is equal to pi by 3. Okay, we have to find the first and second derivative. This is given, find dy over dx and d square y over dx square. Okay, we have to find this one. For dy by dx, we need dx over dt. What is the derivative of dx over dt? What is the derivative of secant t? Anybody? What is the derivative of secant t? Secant t derivative is secant t into tangent t. Okay, and what is the derivative of tangent? Tangent derivative is secant square of t. Okay, so we have a formula for the first derivative. For the first derivative dy over dx, that is equal to dy over dt divided by dx over dt. Substitute these two values here. What secant square t divided by secant in t into tangent t. One secant and one secant cancel. So dy over dx is equal to what? Secant divided by tangent. Okay, secant divided by tangent. So secant divided by tangent means, secant means what? 1 divided by cosine of t, and tangent means sine of t divided by cosine of t. Okay, cosine of t and cosine of t cancel. We only left 1 divided by sine of t. 1 divided by sine of t means cosecant of t. Okay, so this is the first derivative. So the first derivative y dash, or you can say dy over dx, that is equal to cosecant of t. Okay, for the second derivative we need the, we have a formula, this one, d square y over dx square, that is equal to dy dash over dt and whole divided by dx over dt. Okay, so for this one we need the derivative of this value. What is the derivative of cosecant? Dy dash over dt. What is the derivative of cosecant t? Anybody? Maybe you forget, but I know you remember when you studied calculus 101. So the derivative is cosecant t into cotangent t. Okay, and this value is same this one. So substitute these two values. What I will got? Minus cosecant t into cotangent t divided by secant t into tangent t. Okay, so how you can simplify? You know that cosecant is 1 divided by sine of t, and cotangent means cosine of t divided by sine of t whole divided by 1 divided by cosine of t into sine of t divided by cosine of t. Okay, so if you simplify, this will become minus cosine of t divided by sine square t divided by sine of t divided by cosine square t. Okay, so you can write this one is equal to cosine of t divided by sine of t sine square t multiply with cosine square t divided by sine of t. If you simplify, that is equal to minus cosine cube of t divided by sine cube of t, which is equal to minus cotangent cube of t. Okay, so if you don't want to simplify this one, you can only use the first equation to put this value, but it will be lengthy. Okay, you have to put pi by 3 in this one, so you have to put in the first derivative pi by 3. Okay, which is the first derivative is this one, which is equal to cosecant into pi by 3. When you calculate, cosecant into pi by 3 is equal to 2 divided by square root of 3. For the second derivative, if you substitute the value t is equal to pi by 3, you can substitute either in this one, or if you can simplify, you can put here. So cotangent of 3 into pi by 3. So that is equal to minus 1 over 3, like this one. Okay, so you can calculate from the calculator this value. You can substitute the value pi by 3 here. Cosecant of pi by 3, cotangent of pi by 3 divided by secant of pi by 3 and tangent of pi by 3. From the calculator, if you calculate this value, you will also get the same result, 1 divided by 3 into under root of 3. Okay, so this is from the calculation. So this is the simple method to solve the parametric equations and find the slope of any parametric equation. Okay, so any question you have, you can ask me. Any question? It's clear. Okay, so for the slope or the for this second order derivative, you should know these formulas: dy over dx, which is equal to dy over dt divided by dx over dt. The first formula, this is the first order. Okay, if you want to find the second order, if you want to find the second order derivative, then you have to find the, if you have to suppose this is a variable. For example, this one I suppose y dash. Okay, so you need to find the derivative of this one with respect to t, and the down should be same, dx by dt. So this is the second derivative. Okay, for example, if I ask you to find the third derivative, so the first derivative is this one. Okay, anything. Second derivative, you say this one. For the third derivative, third derivative, you can find the derivative of second derivative with respect to t, and down is same, dx by dt. Okay, so fourth is you have to find dy by d3 divided by dt divided by dx by dt. Okay, so you have to use the first derivative in second derivative, and in second derivative you in third derivative you have to use the third one, second one. Okay, so any question?